Today we will discuss the next chapter, that is addition, elimination, reactions and reactive intermediate in organic synthesis. So first of all we will discuss the addition to carbon-carbon multiple bond. So the addition reaction, depending upon the initiative of the reagent, we can classify the addition reaction into three different type of category, that is electrophilic addition reaction and nucleophilic addition reaction and free radical addition reaction. In this type of addition reaction, as the name suggests, these reagent will act first. So in electrophilic addition reaction, electrophile will attack first followed by the nucleophile, and in the nucleophilic addition, nucleophile will attack first then followed by the electrophile, and in the free radical is the starting of the addition reaction. Now first of all we will discuss the electrophilic addition reaction to carbon-carbon multiple bond. In general mechanism, we know that the addition usually occurs especially in the case of electrophilic addition reaction, addition occurs in multiple bonded organic compounds. In the case of electrophilic addition reaction, our substrate is an alkene or any multiple bonded compound, and that substrate multiply bonded compound are electron rich in character. So in this reaction I have shown an alkene which is symmetrically substituted, and in which the X, that is the electrophile, is added first then followed by a nucleophile, that is Y minus. So we will get an alkane. So in this reaction an alkene is converted into alkane, and the pi bond is converted into the 2 sigma bond in the addition reaction. So this reaction occurs through two different steps. First step is the addition of an electrophile to an electron rich multiple bonded compound. Here it is a symmetrical alkene, and Y plus is an electrophile. So first of all Y plus attack the Y plus, that is the electrophile, attack the alkene and to form a carbocation, and depending upon the stability of the carbocation, the nucleophile W will attack this carbocation and we will get the final product as an alkane. So this is the general step in the electrophilic addition reaction. Now the electrophilic addition reaction may occurs in a triply bonded compound, and here in this example our starting material is acetylene and our electrophile, and both the electrophile and nucleophile are the chlorine here. That means we are adding the chlorine to the acetylene. So there is a partial positive charge is developed in chlorine, in one of the chlorine, and other chlorine a partial negative charge is developed. First of all, the chlorine electrophile will attack the acetylene and to form a carbocation, and since the electrophile, that is the chlorine, have lone pair of electron, so the lone pair of electron assist the carbocation, and finally the nucleophile Cl minus ion will attack this carbocation, and finally we will get a chlorinated alkene is produced. So here the speciality of the addition is that both the electrophile and the nucleophile are the same atom. Now we are moving into the addition of an electrophile to an unsymmetrical alkene. In the first case our starting material is symmetrical one, and our reagent is also symmetrical. In the second case we are adding a polar molecule to a unsymmetrical alkene. See here in the alkene we can see that a doubly bonded carbon is present. So one of the doubly bonded carbon atom is attached to a substituent CH2CH3 and the other one is hydrogen. Whereas in the next side, both the substituent of the carbon is hydrogen. So during the addition, first of all, the electrophile H plus is added in the multiple bond. So here a one question arises where the H plus will attack either the carbon of the substituent, both the substituent are hydrogen, or the carbon in which the one of the substituent is alkyl group and the other one is hydrogen. Which side the hydrogen plus, that is electrophile, will attack? Naturally, the H plus attack in the less hindered side, because here in this reaction a carbocation is generated and the carbocation must be stable. So that's why we know that the stability of the carbocation are in the order tertiary, greater than secondary, greater than primary. Since if the hydrogen attack in the carbon atom which is less hindered, so we will get a more stable carbocation. So here it is a secondary carbocation, that's why the carbocation is highly stable, and after that nucleophile Cl minus will attack the carbocation and we will get the final product as like this. Okay, this is the mechanism of the electrophilic addition reaction, and we will discuss both the addition to the symmetrical alkene and unsymmetrical alkene, and similarly the addition of a symmetrical atom, that is X plus, X2, and unsymmetrical, that is polar molecule. Now we are moving into the stereochemistry of electrophilic addition reaction. So before that, we have to consider that there are two different type of the addition in alkene. First one is anti-addition, that means electrophile and nucleophile are attacking the alkene in opposite direction, that is anti-addition. Whereas in the syn addition, both the electrophile and nucleophile approaches the alkene on the same direction. So these are the different type of addition. See in this example, it is a planar molecule and both the methyl group are on the same plane. If the hydrogen and bromine are attacked in the opposite direction, that means anti-addition. Here I have written in anti-addition. Then bromine and hydrogen are exist in the different plane. Whereas if the hydrogen and bromine added in the same direction, that is a syn addition, then in the resulting product we can see that the hydrogen and bromine are exist in the same plane. Okay, and this plane is away from the plane in which methyl group are exist. Now we are again moving into the mechanism of electrophilic addition reaction. So first of all, a symmetrically substituted alkene is added to the bromine is added to a symmetrically substituted alkene. And we know that the bromine contain a lone pair of electron, and that's why first of all there is a partial positive charge exists in bromine and similarly partial negative charge exists in the other bromine. And first of all, the partially positive charge bromine, which is act as an electrophile, will attack the alkene. Then there is a carbocation is generated at first, as we discussed in the mechanism. And we know that the bromine contain lone pair of electron. That's why this carbocation is stabilized by the electron of the bromine atom. We have already discussed this type of the assistance of the carbocation in neither group participation also. And similarly, the carbocation is formed and there is a cyclic bromonium ion is formed, and and after that the bromine Br minus, that is the nucleophile, will attack in the opposite direction. See the figure, opposite direction. So the resulting product in which the bromine are in the opposite direction. Okay, now the syn addition is also possible. That means addition of a electrophile and nucleophile on the same direction. See the last example in the bottom of the slide. That is an symmetrical alkene CH2CH2 in which a polar molecule is added, that is HCl. And here the hydrogen is a electrophile and the Cl is a nucleophile. First of all, the hydrogen, that is an electrophile, is added in an alkene, and we will produce a carbocation, and that carbocation is stabilized by the nucleophile Cl minus ion, and this pair is exist as an ion pair. After that, the Cl minus, that is the nucleophile, will attack the carbocation in the same direction of the attack of the electrophile. So we will get ethyl chloride, and both the hydrogen and chlorine are on the same direction. And now next we are discussing the addition reaction, that means syn addition to a E and Z alkene. We know that in the unsymmetrical alkene there are two isomers are exist. One is the Z isomer, the second one is the syn isomer. The Z isomer means both the substituent of the alkene are on the same direction, and in the E isomer both the substituent are in the opposite direction. See, in the first example I have shown, in which the doubly bonded carbon atom is attached to a two substituent A and B. If both A are on the same direction, then we call it as Z alkene, and if both A and B, A are on opposite side of doubly bonded carbon atom, then we call it as E alkene. First of all, consider a Z alkene, and if you are adding the polar molecule in the same direction, that means syn addition, in which both the electrophile and nucleophile are approaching the Z alkene in the same direction, we will get a erythro form. Okay, the first case. Whereas in the second case, that is a E alkene, that means both the substituents are on the opposite side. If you are adding the polar molecule in the same direction, that means a syn addition, we will get a trio form. That means see the structure of the alkane which is formed during the syn addition, and the resulting product is a trio form. Trio form means both the substituent A and B are on the same side. A and B are on same side, whereas in the trio form, A's are on the same side and B's are on the same side. Okay. Now we will discuss the trans addition to E and Z alkene. Trans addition means a polar molecule are adding in the opposite direction to an alkene, and alkene must be either E or Z. And I repeating, E alkene means the substituent which is attached to a doubly bonded carbon atom are on the different side, whereas in the Z alkene the similar group attached to the doubly bonded carbon atom are on the same side. If you are adding an polar molecule to a Z alkene in the opposite direction, that means anti-addition, what will happen? We will get a trio form. That means the electrophile are approaching the alkene on the top, and nucleophile will approaching the electrophile in the bottom. So we will get the trio form as the final product. Whereas if the molecule is attacked by the alkene is a E alkene. Okay, in the bottom of slide I have shown the E alkene. We can see that both the product, if the electrophile are on the top or if the electrophile are on the bottom, any way of the anti-addition we will get a trio form. Okay. So in the syn addition, if our alkene is a Z compound, we will get a trio form as the final product in syn addition. Whereas if the starting material is a E alkene, in the syn addition we will get a trio form as the final product. So in trans addition, if it is a Z alkene, we will get a trio form in anti-addition, and in the E alkene we will get a erythroform. I hope that you understood the concept. Thank you.